Okay, we are going.
All right, thanks. So yeah, welcome everyone to today's office hours. Going to get my screen shared here. Today's topic that we're going to be covering is focused around our upcoming OAuth Toolkit 4.6 release. And this release is going to be coming out next week at this point. Right now, it looks like we should have it out by the end of the week, of maybe not a day or two earlier. All right. But definitely looks like we were on track for that for this coming week. Um, we're very pleased to have with us the engineering team that are the ones that are actually doing the work on most of these features, and so they'll be here as part of this call to help us dig into details and provide us with more information about the individual features within the release. So we're going to cover just a general update. I'll be covering that, and then we'll jump into three of the kind of the core highlight features of the upcoming release. The first feature is around FAPI 1.0 support in support of open banking. Then we have two new grant types that have been added as part of the release. One is the device authorization grant type, and one is the token exchange grant type. Just a quick refresher for if there's anyone on the call that is maybe not familiar with the OAuth Toolkit, otherwise known as the OTK. Just wanted to make sure we kind of level set on that. Um, the OTK is a add-on solution kit that runs on top of the existing Layer 7 API gateway. It's actually included as part of your general API gateway license, but it is a separate solution kit that you install because it's optional and not every customer needs or wants it running on the gateway. It provides an OAuth 2.0 and OpenID Connect full implementation, right? So we're providing both the capabilities of the resource server, the authorization server, and the token server. And the OTK is pretty widely used across a large variety of our customers. So definitely intended for high enterprise grade security, right? Reliability, scalability, all the things you expect for a kind of a large scale deployment of OAuth. It includes web-based administration interface, and one of the main, I'd say, highlights of the OTK is it's extremely flexible and extensible. Right, the OTK is implemented via policy, and that policy is there within the gateway where you can actually see it. There's a complete framework of customizations that enables you to come in and easily modify how the OTK may integrate to other things, may slightly change the flow or the way some things work. So it is very easy and very flexible in terms of how you can extend that. So yeah, with that, I'll jump into some more of the specifics here of the actual release. Um, One thing to note, so the release, I've kind of got the gold star there. You are here, right? We're right on the cusp of this release coming out again, scheduled for next week. So this will be the 4.6 release. The latest versions to the left of your screen, right back in the Q1 timeframe. We had the OAuth 4.5 that was released in GA. And then we made a minor update to a 4.5.1. So those releases are the latest and greatest. Once 4.6 does come out, we will most likely announce an end of support for the 4.4 version of OTK. You see at the bottom of the screen, the end of life for 4.2 to 4.3 happened at the very end of last year. So we will expect that we will also do an announcement for 4.4 with a 12-month notice, right? So you'll have at least 12 months to move off of 4.4 onto either 4.5 or 4.6. And we will then be planning another incremental kind of 4.6.1, most likely sometime towards the end of Q1, maybe slightly in the Q2 kind of time frame of 23. And that'll continue to build on some of the features that we'll be discussing today. Are there any questions on that before I move on? All right, if not, so from an OTK feature point of view, so as I mentioned, the current plan is to release 4.6 by the end of this month, next week. The the core features here that we'll be talking about today in 4.6 are around FAPI 1.0 compliance, so both the baseline and advanced profiles, as well as the JARM support. We've also added the ability to support the software statement as part of RFC 7591, and then the two new grants I mentioned for token exchange and device authorization. Candidates for the later 4.6.1 release include the support for the SIBA profile for the poll mode part of that, and then the PAR and RAR support, which are again related to open banking and around the overall FAPI support. Then we'll be looking at upgrading, to conform with FAPI 2.0 as needed, and we'll kind of be looking at that. So those are the primary candidates for 4.6.1. Doesn't mean they'll all necessarily fit in 4.6.1, but our goal is to try to have that in that time frame. Okay. With that, I'm going to turn it over to Raju from our development team, who's going to talk more about FAPI.
Thank you, Greg. Hopefully I'm audible to everyone. Good morning.
Yes, yeah, you're audible. Do you want to share your screen, Raju?
No, let me continue for the slides. Then once the demo comes, I'll take it over.
Perfect. All right, thanks.
Yeah. So good morning once again. So I'm going to talk about FAPI compliance that we supporting starting from OTK 4.6 release. So basically the FAPI compliance is talking about it's introducing a profile that hardens or secures the existing OAuth 2.0 and OIDC framework basically. So the reason is certain financial grade APIs requires more security and interoperability. So while especially asking the end user to authorize. So that's where these profiles are coming to picture, and those are well defined as per the spec. And our OTK 4.6 is going to compliance. So yeah, basically it introduces two profiles, one for moderate APIs where you don't really see much risk sharing some of the information through the front channel especially. But if you are really concerned about exposing some sensitive information to the front channel, then probably we should switch to the advanced profile. So both are independent, but actually advanced profile includes basic profile also. With some exceptions. So, but otherwise advanced profile is more hardened than the basic profile. So yeah, so that's about the FAPI compliance. So should we move on to the next slides, Greg? Yeah. So in this slide, I would really talk about the baseline profile, especially. So what exactly it demands from our authorization server point of view and the resource server point of view. So it provides few guidelines like, as I told you, the main aim of supporting these profiles is to harden the front channel communication between your application and the authorization server. So when I say the front channel, it's basically we make a request to the authorization server over the authorized endpoint, but most of its inputs are going through the query parameters. So when we say the query parameters, those are exposed basically. So that's why it put forward some hardening while making the authorization request especially. So otherwise, if you take the token endpoint, this is basically meant for the back channel communication. So that means your app, which is running at the server end, would make it to request to the token endpoint. So we call it as a back channel communication. So yeah, I'm just trying to make a difference of what is front channel communication and back channel communication. Yeah. Otherwise, when it comes to authorization server, so if you run the OTK in the baseline profile mode, then it demands from the client, especially authorization request, should adhere these following rules. like redirect URI should be there in the authorization request, and that register redirect URI should be over HTTPS schema only. And in some instances, like when scope is defined as OpenID, then you must provide the nonce parameter. And if it is not, then at least you should provide the state parameter. So that means without these profiles in active, so you don't see these kind of hardened requirement over the authorization server point of view. But as soon as you enable baseline profile, you will see them all these mandated by the authorization server. So your clients which are adhering to the FAPI profile requirement profiles like a baseline or advanced, so ensure making the right requests which are meeting the basic baseline profile or advanced profile. So that's about the authorization server. And when it comes to resource server, yeah, there could be more, but you will find more illustrative rules and regulations from our tech docs basically. So in the interest of time, I'm not really reading each and every point, but so there are few bunch of requirements like this. And to highlight something, so when it comes to client authentication method, there is a even uh, some kind of mandate like it should be using the client secret JWT, private key JWT, or MTLS at least. So otherwise token and you will see the failures at the token endpoint if you don't use one of it, especially for the baseline. And when it comes to advanced, actually it is even more harder. You will see it later in the next slide. But in the resource, when it comes to resource server, the reason is like gateway acts like both. It has two roles. Like one, it plays the authorization server where the OTK is installed. Other one is resource server where you actually enforce the token to be present in your request. So there, what the FAPI baseline profile demands is it should not, resource server should not accept the tokens via query parameters. So we made a necessary change to the existing NCAS that enforces the token in the request. So where you can choose access token to be accepted only from the body or header basically. So if it is arriving from the query parameter, you can deny it, but by default it is not it is, I mean, we just provide an option over the given NCAS so that whether you are in the baseline or advanced, so you can still enforce this particular requirement. And the other one is logging or auditing the FAPI interaction ID. It is expected to set this value by the client when making the access when making the request to the protector resource. But if it is not so, authorization server would attach this FAPI interaction via the response, so that in the next ongoing request, maybe the client can make use of it. But otherwise, it is expected that client could provide this FAPI interaction ID so that resource server would log or audit this particular value so that it can be trackable, or you will see at least some kind of correlation out of the logs. So yeah, this is all about the baseline profile. So any questions? Otherwise, I'll move on to the next that is advanced. Okay. Uh, Yeah, thanks, Greg. And in the advanced, as I told, it is more harder than the baseline profile. And of course, advanced means it actually takes some of the hardened rules from the baseline as well. So, but a more highlighted ones were even it actually imposes more restriction over the front channel communication by demanding the authorization request should take the request parameter where it carries the JWT that encompasses all the necessary usual authorization parameters. So that because it is a JWT signed by the client private key, So it is more secure than the normal usual communication over the front channel. So that's major here. So and when it comes to response also, response is even the response is also hardened by this advanced profile, where even the response can also be expected like a JWT. We call it as a JAM, authorization response mode. So where you will see all the response details will be delivered as a JWT token, JWT token claims basically. So client should be ready enough to make the request in the JWT as well as accept the response as a JWT also. When it comes to response, so here the JWT is basically signed by the authorization server. So the same JWT JSON will be used by the client to to verify the response, whether it is really come from the intended authorization server or not. And also, basically, as part of the advance, we have introduced a few extra response mode that you have not seen before. Basically, usually you will expect to have the response mode like query, fragment, and form post, right? So when it comes to advanced profile, it demands to be JWT. Hence, the spec introduces few extra response mode like JWT, query.jwt, form post.jwt, and fragment.jwt. So it is required to make an authorization request with one of these response modes, especially you are making the response type of code. But in case if the response type is code with ID token, then this is relaxed a little bit, like the response details are basically protected by ID token itself. So that means ID token carries that is delivered to the response basically contains hash claim that protects the state integrity, state parameter, state value integrity. So so you have two choices here when it comes to make a request, whether I can go with the JWT or not. If it is response type is code alone, you have to specify response mode as JWT, or if it is a response type is code ID token, then it's okay to not go with a response mode equal to JWT. So it's so we have these two provisions when it comes to advanced. And along with it, as we have heard about a lot of queries regarding the ID token customizations, so we made it very simple as part of this. So we are providing a few customization that you will see in the next slide. But otherwise, one last thing under this slide is algorithms. So even the FAPI profiles are mandating to use few particular algorithms. Right now, usually authorization server will use RS-256 or HS-256 for signing, right? So those are not really encouraged by the profiles, FAPI profiles. So you will see the default signing algorithm as soon as will be encouraged or entertained by the authorization server when advanced profile is active, that is PS256. So I'm just ensuring to notice this particular algorithm choice. And Greg, could you please move on to the next slide? Yeah. So this slide basically talks about.
Sorry to interrupt. Like, I raised my hand. Like, I have a couple of questions in my previous slide. Should I wait for till the end, or can I ask now?
Maybe after this slide before I
Yeah,
jump
sure.
into the
I'll
this
wait.
demo. Yeah. Okay. Yeah, so till now we have talked about what has been done, but when it comes to configuration by the end user, so these are the things you can, yeah, by default, OTK will not enable these FAPI profiles. So you need to choose, you need to make a decision whether you need, you want to run your authorization server in one of these modes, that is FAPI baseline or advanced. And because these are cluster-wide properties, these are global level, so we can't expect the same profile to be activated at the client level. So right now it is default level. That means, so once one of the profile is set by setting it to true, then all the clients will adhere to the required rules basically. So and when it comes to the policy level customization, there are bunch of customization where you can customize the default implementation when it comes to JWT request object validation from the front channel request point of view, and generate JWT authorization response when it comes to response point of view. And there is OTK profile configuration which allow you to bring those FAPI baseline and advanced profile settings at instance level. In case if you are if you are running the gateway with multiple instance of gateways, probably you can make use of OTK profile configuration to define the FAPI baseline or advanced at the instance level. So yeah, that's about the FAPI compliance. And as part of it, because the FAPI is demanding few extra thing like introspection API, till now we did not provide a spec compliance introspection API. So we were fulfilling as part of the OTK 4.6 release. And I was talking about ID token customization, right? So we have introduced few more custom policies where you can define your custom claims so that that can be made part of the ID token generation, and as well as when it comes to validation, they will be honored. So using these two custom policies. So this is about all the story of FAPI compliance. Yeah, before I jump into the demo, yeah, I'm welcome the questions, please.
Sure. So in this slide itself, I have one more question. Like you mentioned, like there is a new cluster property being introduced about the baseline and FAP. Is it we can enable any one at this point since it's being a clustered property, or is it possible to enable both and we can use both in a different scenarios?
Yeah, you can set both of them together, but I told you right before, FAPI Advanced means it actually includes the baseline as well. So whether you set the baseline when the advanced is active, it doesn't really matter. So we encourage you to choose one of it so that it would be more explicit about your choice.
Got it. So in case if I want to use both in our scenarios, like I would enable advance and still I can use baseline and advance. Is that right?
Advanced means actually say advanced requires more hardening. So if your client is following the only the baseline profile, so
Mhm.
maybe a client would see the failures because advanced is active. It
Okay.
is what I'm trying to say is advanced is superset of the baseline.
No, no, I got it. I got it. Like there are two different consumers, right? And one want to use baseline and another want to use advance. So in
Mhm.
this case, is it possible to use both, or we need to set up a standard that we encourage only advance?
Yeah, so these flags are actually made available at the global level. So we could have not we could have done it at the client level, but in case if they are at the client level, yeah, you would expect that scenario possible. But right now, it is not possible.
Okay, so it is either or, like either we have to go like a full baseline with all consumers, or advance with all consumer. Okay,
That's correct.
okay, got it. And if you don't mind, can you please move to the previous slide? Yes, and about the algorithm, right? The signing algorithm, you said like PS256 is what encouraged. Is it like a mandatory or it's like a nice to have feature like
No,
PS2?
it's mandated, but there are other algorithms also like ES256. but we chose PS256 as the default signing algorithm.
So default. So or RSA 256 is not supported, like in case if somebody.
No, it's not part of the spec FAPI compliance, so we we
Okay,
can't
got
expect that that is honored. Yeah.
it. Yeah, sure, I got it. And about the request, right? And request, the second point you mentioned, like shall only issue sender consent access token. And
Mm-hmm.
so which little confusing. So as part of the request, somebody would send the sender access, or after completing the request validation, and layer API gateway would generate and sender access constraint access token.
No, see, let me explain. So, authorization server basically issues a sender constraint access tokens. Means the token that is issued will be thumbprinted with some certificate. So, if the client is submitting a token in order to access any protected resource, so client should make use of the MTLS. So then only it is proven that the given issued token is actually issued to the given application or not. So that's what the sender constraint means. So it is even from the client point of view, to access any protected resource, they should even to use MTLS also. MTLS or private key JWT. So whatever the way the resource server is protecting your enforcing the protected resources, so should expect the MTLS authentication to be there activated.
Okay, so if I understood right, it is like say for example, we use the MTLS as a default. That is being a standard for us. Okay,
Yeah.
so MTLS is default. Then is it wise to use the sender constraint access token as well, or only the key value pair access token or structured access token?
I'm sorry, I did not get your question about
So, so,
key
so
value
what I'm trying
pair.
to ask is like again, MTLS and the sender consent access token is kind of a either or feature, or we should use mutual TLS as well as a sender consent access token both, MTLS and sender consent access token both.
No, see, MTL is basically a mechanism to for authentication purpose, for
Yeah,
client-side authentication.
yeah.
Whereas the access token, when we call it as sender constraint, means access token carries some proof saying that it should be presented to the resource server over the MTLS alone, so that it can be proved by the resource server, yeah, whether the access token is really coming from the actual sender or not.
Okay, yeah, both functionality understood. So is it wise to use both or not? So that's what my question is. So
Uh,
MTLS plus sender consent access token should be issued or no?
Yeah, we have to use both.
Both.
Then only it works.
Okay.
That
Got
means without MTLS, you cannot submit sender constraint access token. You cannot present sender constraint access token to the resource server. So a resource server can won't be able to identify whether it is really coming from you or not, because
Okay,
you have not been authenticated.
got it.
Yeah,
Okay, only if we share these keys previously, then we send and sender access constant access token to them, and they would be able to validate this
yeah,
access token. Okay, okay, got it. Thanks. That's it.
yeah. Any more questions? Okay, Greg. Let me jump into the demo. So, can I start sharing my screen?
Yes, go ahead.
Yeah. So I hope everyone can see my screen. Yeah. So I've already configured my client applications in the interest of time. So this is my application I'm going to use for this particular demo. and probably it is timed out. Let me quickly connect it. Yeah. So I have already registered this particular application, OAuth application. So and allowed response types are code and code ID token. And of course, I have listed here token also for the sake of errors. Yeah, so let me jump into the execution by making few authorization requests. So for that, I'm using the Postman for initial request, authorization request composition. So initially, so let me show you what if I don't meet the requirement to the baseline. And for that, I need to set my gateway into the baseline, right? Yeah, for that. I need to switch from one window to another frequently, so please bear with me. So these are the cluster-wide properties I'm listing, and this is not a default choice, of course. The default is this one. You will see as soon as you install the OTK 4.6, you will see these cluster-wide properties populated with the false. So that means gateway is not really running with any FAPI compliance profiles. So let me activate baseline. And I have activated the FAPI baseline. So here I'm going to make a request here. So that is this one. So it is likely to fail. Let me check. The reason is it is not meeting one of the requirement, that is not using the PKCE. So let me check that. So actually I just made a request to my internal application, that is FAPI. Let me show you this FAPI app. This in turn helped me to create a required authorization request. So I'm just using for that purpose. So I made a request to my application and it composed authorization request here. So I'm going to click on this, and it says actually it got redirected. Let me actually enable developer tools so that you will see it. Yeah. Okay. Sorry. Yeah. So I'm going to click on this. So it went to the authorized endpoint first, and then it immediately gone into my redirect URI. But unfortunately, it's an error. The error says code challenge method is invalid. So that means, so this is one of the requirement from the baseline profile point of view. So client should be using the PKCA. But if I disable this, so it should be working fine, basically. So I have been redirected to the login page, basically. So that's about the FAPI baseline. So, and if you really notice, most of the errors now you will see from the error via error redirect URI. As soon as the client is valid, if the client is, as long as the client is valid and you have provided the proper redirect URI, you will see most of the errors sent to the client application over the redirect URI only. So, and yeah, so next is my next demo would be yeah, let me make authorization FAPI advanced immediately. So I'm going to true. So now it is in advanced. So in advanced, basically, some of the baseline rules are relaxed. That is, PKCS is not really required because it has other way to secure the front channel communication. So that you will see it now in action. So I'm making the same request again. And if you notice, I'm using the response type code and ID token. Response mode is fragment. And I got this one. So it looks to be little bigger, right? So the reason was it composed a request object for me. So let me close this. So request object basically contains, I will show you the request object here. So request object carries almost all the usual authorization endpoint parameters as it claims. In this case, you will see response type, response mode, redirect URI state, whatever I mentioned initially. So along with it, you will see a audience and NBF ISS. So here the audience should be authorization server ISS basically, because this JWT is meant for the authorization server, right? So the client should populate audience field with a authorization server identifier. So yeah, so that's about this request object. Let me continue with this, whether our authorization server really honored this or not. So it actually honored this. So let me continue. And I got code, which is actually fragment. I specified as a I specified the response mode as a fragment. Hence, I got the code and the ID token here itself. I told you in the beginning, right? If you have really noticed, there are two response types which are allowed for the advanced profile. One is code ID token, other one is code. We have used the code ID token, hence you have got the response as the code and ID token here. And before I jump into how to secure the response here, because you will see the response, this code and ID token are exposed in the front channel, but even we can harden it. We can expect the actual response from the authorization server as JWT also. So for that, we need to mention response mode as JWT. Probably I can show you right away for simplicity. So I'm going to mention JWT here. And I'm copying this. And probably, yeah. So this time you got only one parameter in the response, that is a response itself. So this is a JWT basically. So let me capture everything and I can show you what are there inside the response. So let me clear this. Oops. Uh, yeah. So this actually carries our usual response parameters as a claims. And if you notice, the audience is the actual client ID. And more importantly, it is carrying the code and the ID token. That's what we are expecting because we mentioned the response type as code and ID token. So that's about hardening the response. We call it as a JAM. So we can only expect this kind of response if you specify the response mode as JWT. And of course, you can use this feature without activating any profiles. It still works. So that's what that's how we have implemented as a loosely coupled. So not every feature is tightly coupled to FAPI profiles basically. So wherever we could expect that can be used in isolated manner, we made it available to the end user. And yeah, so I would like to show you ID token also, right? So yeah,
There's a
this is the
question real
ID
quick,
token.
Roger.
Sorry.
There's a question.
Yeah,
Yes,
questioning.
yes, Raj, like one quick question. Like when you were showing the demo about compliant with FAPI Basic and FAPI Advanced, right? So let me tell us our scenario that we use an authorized service a lot in our environment, and where even fairly like open ID also we use. So again, what are the parameter you have shown, right? The non-state and the redirect URI and whatnot. Like all this we use as per the authorized standard.
Mhm.
And when we enable, say for example, like a basic FAPI to support some consumer who needs the FAPI, and we enable that, which means that our existing authorized service consumer going to be impacted because of not using the Pixie.
Yeah.
Okay. And
See, for
yeah.
the entire the FAPI, there are three things should be adhering this particular FAPI compliance rules. One is the client, and other one is the authorization server and the resource server. So everyone should be in the same page in order to make this work.
Yeah, so right now it's a global setting, right? So if we need to go and do something different per each client, then that would be a change, or we'd have to implement you know different instances of the OTK for those different scenarios, right?
Okay, great. In this case, do we need to have a separate set of instances running to support both FAPI consumer and also our existing consumer, or is there any workaround or any other way which we can make with one OTK or one instance?
Yeah, right now with the 4.6 in place, because we have provided profile settings as global level, so you need to have two instances to honor two set of clients here. So probably in future uh, we could uh, we could make this possible with one instance. We have
Mhm.
That's
to
a
see how that
that's
is
an
possible.
enhancement. Yeah, enhancement that we'd have to consider, but yeah, we could certainly take a look at that. Yeah.
Sure, sure. Maybe I will put it different thread or email to you, Greg, like our requirement. I feel like more than I mean, we are planning to use advanced. Maybe I will get in touch with you. It's offline.
Yep.
Over.
Sounds
Okay.
good. Yeah.
Thank you.
Yeah, Roger, just a quick time check. No, we've got about 15 minutes left total, right? So just make sure we're
Yeah.
leaving time for the other grants.
Yeah. One last thing I would like to show. Yeah. Um, that is. So we have introduced the introspect endpoint, right? So uh, we 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 fulfill the spec requirements in implementing this introspect API. It doesn't mean that we have deprecated the earlier internal endpoint for token introspection that exists, but this is the new endpoint which is adhered to the actual RFC spec. So this is the endpoint, and it would be protected by client authentication. And other requirement is the client should be in some privileged role. Otherwise, not every client can access this particular endpoint. So we expect that this is really meant for the resource server to in order to introspect the token, or maybe some certain clients where he wants to validate some third-party token. So the setting that I would like to show you is uh, maybe just a minute. Probably, yeah. cancel date. Yeah, this is the setting. So at the client level, you need to define the one field called privileged, and it should be set to true, so that this client is treated like a privileged client to access the introspect endpoint. So what I'm trying to say here is, if it is not the case, usual clients cannot access the introspect endpoint, and you would expect the response from the token in, introspect response look like this. So if the token is to be introspected is still active, not expired, you will see the active field populated true, and other fields that are associated with the access token will be populated here. And in case if the token is expired for some reason, then no other fields will be populated, and you will see the response containing one field that is active set to false. So, and one last thing I would like to demo regarding the ID token customization is, I told you, right, we just introduced few more extra custom policies for introducing the custom claims. So that is ID token custom claims. Here you can define your JSON containing the custom claims, so that that can be reflected in the issued ID token basically. So how we can do that is by setting the custom underscore claims with some JSON payload like this. So probably we can quickly show that by executing the same request one more time. Sorry, not this. And my response type is code and ID token, so that we can see the ID token quickly. And I got the response. Oh, this contains. Oh, I need to decipher twice here because I choose the response mode as JWT. Yeah. So this is my custom client. So that's all for now as part of the FAPI compliance. So yeah, handing over to Greg.
Thanks, Raju. Yeah, let's try that quickly. See if we can get the token exchange and device authorization grants covered. So I'll turn it over to Srinivas next to discuss token exchange. Srinivas, do you need me to share the slide, or do you have it?
Yeah, I'll share the slides, Greg. Let me share my screen.
Thank you.
Good morning and good evening, everyone. Token exchange protocol allows clients or resource servers to exchange the token from the authorization server, acting as security token exchange service, so that clients can get a new token with the right privileges to access the resource. Let me explain that in detail. So in OAuth 2.0, a client application requests access token from the authorization server, so that the client can use that token to access the user resources on behalf of the user. But in API to API call, like I shown in the diagram, when client application calls API deployed on the resource server, the server internally calls another API to compose the response. But if the API 2 is also protected, then the resource server needs access token to access the API 2. But it cannot use the same original token to access the API 2, as the original token is intended for API 1. So this problem can be solved using token exchange protocol. So in token exchange protocol, when client application calls uh, resource server using the access token, the resource server uses original token as subject token and exchanges it with the new token with the with API 2 as the intended audience. then it uses exchange token to call API 2. So in the diagram, we can see that the original token has audience as API 1. So it accessed API 1, but resource server needs to access another API. So it has to exchange the original token with the new token. So it called authorization server with token exchange grant and audience as API 2. Then it gets a new token and uses that token to call API 2. So this is about token exchange. Uh, um, Again, we have two types of flows here. This flow is called impersonation because that new token that we have will not have any information about the resource server. It just impersonates the original client. So this flow is called impersonation. We have another flow called delegation in which resource server uses its own token along with the subject token so that the generated token contains information about the actor token, that is the resource server. In OTK, we are supporting both impersonation as well as delegation. And we are supporting different types of subject tokens such as access token, ID token, SAML1, SAML2, and JWT tokens. And similarly, we are supporting access token and ID token as actor tokens. And we have given a few set of customizations to customize our subject token validations and also to configure token exchange, exchange token lifetime. So with this, I will jump to demo. I will just show the same example that I have explained in this diagram, where I have configured two gateways. The first gateway is acting as authorization server as well as resource server, and API 1 is deployed on the first gateway. There is another gateway which is acting as a resource server, and it has API 2. Okay. So let me just yeah, this is the first gateway where we have API 1 deployed. So if you see here, this API is protected with access token, OAuth 2.0 token. So it requires OAuth 2.0 token. Then it calls API 2 in composing the response. So, but API 2 requires another token because we cannot use the original token that we have got in this request. So it uses original token and exchanges that token with new token from the authorization server. Okay, so the new token what we get will be used in the second API call, and then we respond back to the client. I have already registered a client. I have already registered a client in OTK, and this is the client ID I'm using. And I'm using response type as token. Now I'm calling authorized endpoint in the OTK to get a new access token from the authorization server. So now user authorizes this client. Before that, user has to be authenticated. So user has given the authorization to access the API 1. Now we got a token. So I'm using this token to call API. Okay. I'm using Postman to call API with new token. So yeah, we can see the response here. like API 1 requested API 2 with exchange token. So this is the token we used in calling API 1, but internally exchange the token with a new token and use the token to call API 2. And this is the API 2 response. So I'll just show like the parameters that we use for exchanging the token. So this is the policy I used. So if you see here, so I'm this resource server is calling a token endpoint to exchange the token, and we are using grant type as a token exchange grant, and we are using original token as a subject token, and we are using client credentials to for client authentication. And if you see here, the audience is API 2, so the new token will be issued for accessing API 2. Yeah, that's all I have. Any questions?
Great. Thanks, Srinivas. If we can jump over to Abhishek for the device authorization flow. We'll try to squeeze that in here real quick.
Sure, Greg.
Thank you.
Hello, everyone. I hope you can see my screen.
Apologies, I was I had a questions. I couldn't unmute myself regarding the previous flow. It's
Token
very
exchange?
quick, correct. This is token exchange and regarding the delegation, as you mentioned at the beginning. For the delegations, if, I recall from the RFC that both the client and the API, let's say API, I don't recall, you said API 1 and API 2, let's say API 1, do they need both get a token, an access token from the server, from the OAuth server, in order to get the exchange token?
Yeah, in delegation,
delegation.
we need, yes, for delegation, we need original token that has to be exchanged, and also the actor token, which is like the one who is calling.
And
In this case, it is a
yes,
resource server. Yeah.
okay, so basically you need to first to get those two token, and then you pass it to STS, you get the token exchange as the third one.
Yes, correct.
In a way. Okay, thank you.
Yeah, hello, everyone. Abhishek here. So the third and the last feature today we are going to discuss is about device authorization grant. So basically, the device authorization grant comes into play where we have some devices which do not have a way to obtaining tokens easily using an user agent or anything. So in those cases, they need to rely on a different device where user has access, where he can authorize the device with a token. Okay, authorize the device and grant it a token. Okay, so here we have three parties. So device client, which is basically in our let's say example as smart TVs or some remote devices. So they require access to some resources. So what they do is, so the second party is the user, end user, who has access to some browser or some way to authenticate, and third party is the authorization server who does the token issuance and authorization. So the device client first identifies with the authorization server. So once the authorization server confirms the device identity, it issues three important things, that is device code, user code, and verification URI. So this information will be visible to the user. So with this information from the device, uh, the user will go to the verification URI, authenticate, and use the user code provided in the device authorization response, and grant the request. Okay, so the once the grant is when authorization grant is completed, the device client can get that access token, and then use it to access protected resources. Okay, that is the complete flow for device authorization grant. Okay, so to implement this, what we have done is we have introduced two new endpoints. One is device authorization and device verification. So device authorization is the first call that is made by the device to get the user code and verification URI, device code and verification URI. The second call, the device verification, is intended for the user to log in and do the verification of the user code and grant. So these two endpoints has been introduced. In between, when the user is actually verifying and granting, the actual device tries to poll the token endpoint and tries to get the token. Once the user has granted, the poll request will be successful and a token will be granted. For that, a new grant type has been introduced, that is OAuth grant type device code. So these are the high level changes that have been done. And there are some miscellaneous information which I wanted to pass for the customers, which makes their life easier to in terms of configuration and extension. So we have introduced three cluster-wide properties: device auth code lifetime, token endpoint polling, and verification session lifetime. So device auth code lifetime will determine the auth codes, the device code the lifetime, which is defaulted to 300 seconds. Okay, and endpoint polling is indicated by the authorization server to the device, telling how many times it can poll, the duration of polling, so that it's not bombarded with requests. So that information can also be configured at the authorization server in OTK. Then finally, the device verification session lifetime. So this is actually the user session for the device verification login. Okay, these three information can be customized. Okay, and we also introduced something called device metadata. This is a addition to what spec says, is outside the spec. So we felt that capturing some device information during device authorization is very important. So it can be stored and maybe used for some purposes. So for that reason, the device can optionally send some device information like name, make, model, or something. So to the authorization server, that get persisted in the OTK database, and it will also be part of token custom field in the token. So this, and finally, we have two customizations, that is DAG response and DAG consent display details. These are mostly UI level changes which can be tweaked to suit the needs of the customers. So I'll quickly jump to the demo. I'll take the questions towards the end. So we have the demo should clarify a lot of things. So let me just open up. So this is let's think this as a device trying to access uh, trying to get access, okay, to some resource. So it needs token. So the first step, let's call this Chrome web device, and it tries to talk to authorization server and identify itself. So basically generating the device code. So I'll try to generate a device code here. So here you can see that it returned a user code and also a verification endpoint. So this verification endpoint will be used by the customers to log in and grant access for the device. And this code is required during verification, the user code. And you can see that in between, this device is trying to poll and see if the authorization is complete continuously every 5 seconds. So now let's say the user uh, he accesses the device verification endpoint in his device. For the demo purposes, I'll open in a new window and he tries to log in. Okay. So once login is complete, it prompts for user code to be provided. So we have the user code. The user will copy the user code and provide here. Okay. And once the user code is verified, right, you can see all the information related to the device, what is being granted in this consent screen. like device name. You can see initially I told Chrome web device, right? That information is being captured, that metadata is being captured here, and the resource which is being requested, the scope, and the client name, and all the details. Finally, the user can safely give a grant to this device. You can see that finally, after the grant is provided, the device successfully gets a token, and device authorization is successful. Using this token, the device can access resources, whatever it is required based on the scope and resource details. Yeah, that's what I had. Uh, please let me know if you have any questions.
Yeah, I have a question about device authorization grant. What is the difference between the multi-factor authentication?
Yeah, the multi-factor authentication, the same device might be used for authentication. The same device will be requesting for resource access. But here, there is one device which is, let's say, smart TV as a general example, where you need the smart TV to access some resources, but there is no option for login. So from that smart TV, there is no access to user agent or anything. There are so many restrictions, constraints. So that device can only make HTTP calls, let's say. So when in those cases, the authentication will be done on a different device the user possesses using the user code and verification URI. Yeah, that is the main difference between multi-factor and device authorization.
In other words, the multi-factor authentication is basically serving the authentication needs, but this one is actually regarding the authorization, because you will be authorizing the request in different device.
Thank you.
Any other questions? Thank you.
Thanks everyone for sticking with us a little bit. We ran a little over on today's session, but Bill, do you have any final wrap up? I think we're done here.
Yeah, I think we're done.
One last thing, like, is it possible to get this PPT by any chance to us?
Yeah, so I guess the recording will be posted, and so I'm not sure who asked that, but if you can send me a note, I can definitely share that with you.
Yeah, the recording will be posted in about 3 hours up on the community site for you guys to preview at your will. So with that, I'll stop the recording and thank everybody for joining us today and look forward to seeing you next month.